Well, it's almost holiday season. Well, I guess it is a holiday season. Happy Thanksgiving, Joel. I guess we both had Thanksgiving. I saw some pictures on Slack of a turkey / cranberry meal.
Yeah, delicious.
Rosemary, you did see that big plate. Joel was not cutting back at Thanksgiving time.
You can't see my belly underneath the camera here, but it's still big.
Yeah, so us Americans are pretty full from the Thanksgiving holiday. It was actually a really nice holiday. We had decent weather in America, and there was really no travel hiccups. Thank goodness, everybody got home safe. This week for the podcast, we have a lot going on. And again, it's one of these crazy news weeks where there's just so much renewable news happening. Vestas is working with TPI on manufacturing blades and maybe making some offshore blades, it sounds like, which would be great for TPI and for Vestas. And then Siemens is going to be closing a plant in Morocco, a blade plant in Morocco. And it looks like OEMs are starting to get out of the blade business and transfer some of the load onto independent operators.
And more good news for Vestas with a big order in Australia, and then a couple of other Australian stories. There's a 1 gigawatt wind farm planned in Queensland that's now been announced it will double in size to 2 gigawatts. And also looking forward, Australia's energy market operator has mapped out a route to 100% instantaneous renewables, which they expect to happen in 2025. So we'll talk about some of the engineering things they have to take care of before that can happen.
So then we're jumping back over to the UK, and we'll talk about Tesla building what would be Europe's largest battery into the grid. And it's right near where the Dogger Bank wind farm is off or coming ashore. So really cool to see those additions to the grid in the UK and see what it can happen in the future. And last but not least, a French man wins the right not to be fun at work. So we'll dive into that, have a little bit of a prelude to our holiday season around the world, and have a little fun with it.
I'm Alan Hall, president of WeatherGuard Lightning Tech, and I'm here with Australian renewables guru Rosemary Barnes and my good friend from Wind Power Lab, Joel Saxon. And this is the Uptime Wind Energy Podcast. All right, Rosemary, Vestas has signed a multi-year agreement with one of your former competitors, TPI Composites. And this gets into the future of who's going to make blades, particularly in the United States, but I think this is going to move worldwide. TPI is already making blades for Vestas, has made them for a little while, in the 2 and the 4 megawatt marketplace. But they're talking about making some investments in expanding production capabilities to handle the V163 4.5 megawatt machine and the V236 15 megawatt machine. And I believe the V236 15 megawatt is an Equinor machine, I think, for offshore, if I remember that correctly. So the TPI has a facility that was making blades in Rhode Island, and they had stopped, but that may be opening again now because it's really close to the shoreline. And there's a bunch of agreements like this. There seems to be a lot of movement around in terms of who's going to be building blades. Is it going to be the OEMs, or are they going to sub out the work? And it looks like, at least in the States, we're going to be subbing out a large part of that. Does that make sense, Rosemary, to start kind of like GE with LM, right? I mean, that was sort of a supplier agreement early on. Is that the future?
Yeah, I think it's the past as well, and maybe it's going to be a bit different in the future. So with GE, it was a bit different because when GE started, they didn't have any blade manufacturing capabilities. So they had LM and TPI making blades for them. They had blade design in-house, but right. I know at LM, at least, they don't, every blade that LM manufactures is a blade that LM designed. They don't do any build to print, but TPI do build to print. I don't know if it's exclusively. They probably have a blade design team as well. And LM, before it got bought by GE, it didn't have any, it didn't make any of the rest of the parts of wind turbines. So it was only making blades to supply to other manufacturers. And all of those manufacturers would use LM blades in addition to their own blades, usually as a kind of a supply chain diversification idea, a little bit of a backup plan in case something went wrong. You don't want to have a single supplier for any critical component, and even if that's something that you're making yourself, that's just something can still go wrong. But I wonder if the future, more of the same, but maybe with increasing emphasis on the third-party supplied parts. And I can see that it kind of makes sense for, like, if you take somewhere like Australia, for example, we're very far away from any existing wind farms. I think most of the blades that go to Australia are made in India or China usually, so it's quite a distance to get them there. It's it has been a big market, and it's going to be a very big market moving forward. There's a lot of plans, and I think we'll talk about some of those later in the episode today. But for a company to start a factory there, that company needs to have lots of sales in the area. Whereas if you have someone like TPI who are making blades for all sorts of manufacturers, and they could supply, Vestas wind farms, they could supply Siemens, or all of them, GE.
Right.
So I can see how it makes sense for new locations like that. And maybe we will see a lot more of that in the future. It's lower risk for the wind turbine manufacturers, at least. It's a lot of work to start up a new factory, and they need to be really sure that their pipeline is, really secure, that they're gonna have orders to fill it for the next few years.
Well, Joel, does it make sense that a TPI builds blades for several different OEMs? And if they're going to do that, especially if, say they're making a 3 megawatt blade for GE, and they're making a 3 megawatt blade for Siemens Gamesa, which eventually will happen, would they just not use the same blade design? Doesn't that make sense? If you're going to be in the manufacturing space, why would you have two molds, two different setups where you can just cause yourself mistakes? Wouldn't it make sense for someone like a TPI to say, hey, everybody, let's just settle on one design here and make it easier? So it can make the products less expensive.
That used to happen in the past. Some designs where you just like, hey, we need some of those LM 40.3s, and you could just bolt them on to whatever turbine you want. But I think as we see wind turbine technology, innovation cycles going so fast, everybody's trying to get that little bit of edge, right? So you start to see more, of course, aggressive blade designs. And I don't think that, and it's for low wind speed versus high wind speed, and the little specifics here and there. And as you see more of those things change, I don't think you're going to see that much. You might have, okay, so say you have a TPI factory and you have a bunch of really skilled technicians. You might, instead of having a 3 megawatt blade that fits a bunch of different platforms, you might have 2 or 3 lines, production lines of different kinds. Because I know like TPI also makes Enercon blades. You know what I mean? So, so they'll make different ones for different manufacturers. And I just don't see while it probably is more economically feasible to have, for the industry as a whole, everybody, all the different OEMs want to have their edge in the marketplace. So I don't think you'll see that. Everybody wants a little bit of a custom thing.
LM did attempt to do that years ago because, they had the same thoughts that you're having, Alan. I assume it's so obvious that, you get the economies of scale, and you can get better reliability if you have more blades out there to learn from. You get, better and better at it every time. But LM gave it a pretty red hot go 10 years ago, or maybe even more. Probably more. They just didn't really sell. I think that the issue is that there's no way to make different turbines. Like to get the edge in technology, to have the best turbine. You can't do that if you can't change the blade. The blade's where it all starts. That's a part that's going to capture the energy, and all the, the loads in the blade are transferred to the rest of the turbine. So, if you all had the exact same blade everywhere across the world, then everything else would start to look very much the same as well. So you kind of stagnate. So I'm not sure if overall it would lead to a better system. So I'm not sure. On the one hand, it makes sense, but on the other hand, I can't actually see it ever happening.
Yeah. Well, Joel, am I wrong about this? But the American auto manufacturers, I don't think Ford makes their own engines anymore, right? I think there's
They make a
talk
couple
about a
of
critical component.
They make a couple of them.
Yeah, right. So
But
they've
not
even
all of them.
outsourced probably the most critical component of the
Yeah.
of the car is
But-
the engine, and
But they set
they're
up
outsourcing that.
they set up agreements too. Like, okay, so now if we're talking cars, like trying to equate
Yes.
the two. If you go tires, now tires are not. I mean, they're a critical component. You can't get down the road without tires. But the tire isn't going to make or break a vehicle, right? Like you can have a little bit. Like if
True.
you're in a Corvette, yeah, your tires are a little bit different than they are in a passenger car. But they don't make or break it. Now the engine and transmission combination, that might be something that make or break that model of car. So even if Ford is outsourcing what engine they're building, they're going to have an agreement that this is the only engine that this thing can go in, besides specific models, right? So
Okay.
so they may have someone
that makes
outsource build it, but they're going to say, hey, that is just for us. That doesn't go in. You know, they're not giving away the what's the new motor they got? The Coyote 5.0 liter. They're not letting anybody else have the Coyote 5.0 liter, even though they're not probably manufacturing it themselves. You know what I mean? So
Yeah, so in that way, it's similar
Yeah.
to TPI making blades for somebody.
yeah. Their blades are outsourced, but that custom model of, like, when we were at Hamburg, Enercon was debuting that 75 meter blade, that the
Right.
I think it's
Yeah.
or the 175 platform, whatever it was. They're not going to, because that's their new hot rod in the marketplace that they're counting on for sales. They're not going to let everybody have that same blade design.
And Rosemary, are these blades really that different? Really?
Yes and no. I mean, they all do the same thing. And, if you gave any designer the airfoils that, Siemens was making and the wind
Right.
speed that it should operate in, then they would come up with very, very, very similar geometry for the blade. So in that sense, no. There's some innovations with manufacturing. And I mean,
Yes.
throughout the years, if you look back at like big changes, they have made a difference for a few years. Like I know at LM, they, you focus a lot on IP and patents and that sort of thing. And every
Right.
patent lecture I'd go to, they would bring up by far the most successful patent that LM ever had was for pre-bending the blades. So, they were the first ones to bend the blades away from the tower when they were unloaded, so that when the wind hit them, when they were operating, they would just kind of get to straight, which is better aerodynamically and also gives further to go before it hits the tower. So that was only LM blades had that for, the life of that patent, which I believe is expired now. And so that was huge for them. And then there's been some other ones as well with materials, figuring out how you can use carbon fiber and preforms and maybe carbon fiber fiberglass blends. All these sorts of things don't sound like, to somebody at the bottom of a wind turbine, that's not something that you're going to notice looking up at it and be like, oh, wow, that's an LM blade. But they certainly made a difference for annual energy production and for, the cost of the blades. Yeah, it's I guess it's, to answer that question, it's like, what's a significant difference? And what's a significant difference to a engineer is maybe different to everybody else.
Right. Well, there seems to be some more consolidation in the blade manufacturing group. Siemens Gamesa is going to close a factory in Morocco, a blade factory, which again goes back to how much work are the OEMs really going to do? If they're closing the blade factory in Morocco, and Siemens Gamesa has a big footprint in Africa in general, it seems like they're definitely consolidating and thinking about offsetting some of those expenses onto another company to take the responsibility of that. Now, Siemens Gamesa cited a whole bunch of different factors for why they were closing the factory, but they are Ukraine, of all things, aluminum prices, supply chain problems, competition, the usual stuff. But that would apply worldwide. Why Morocco? It just, especially since you're close to the shoreline, it makes sense to keep that blade factory open if you're trying to deliver blades up to the Mediterranean or somewhere. That would make sense. But I think the consolidation continues because we also see a shift south towards Australia, of all places. Vestas has got a big project down in Australia, the Golden Plains Wind Farm, where they've secured a big order for 756 megawatts of turbines. So it'll be 122 V162 6.2 megawatt machines.
That's big.
And Joel, are you ready for this? They have a 30-year service and maintenance agreement to go with that.
Wow. I mean, but that's standard in Australia, right? I mean, Rosemary, correct me if I'm wrong, but most of the industry down there runs on FSAs. But 30 years, man.
That's man. The guy who signed that contract.
Yeah, Vestas must really trust in that V162.
Yeah. I'd really be interested to see what's in these agreements in terms of, because you just trust them then to maximize your asset, to make sure that they're, operating efficiently and got the best maintenance strategy, and, an availability guarantee or a performance guarantee that can really only set like minimum acceptable levels. And I'm constantly surprised that developers in Australia don't seem to be concerned about, 2, 5, 10% maybe, improvements that they could be making years into the future by adopting a different operational maintenance strategy. You just kind of, I don't know. You're obviously leaving something on the table if you trust somebody else to operate and do the service, because, say that you've got a problem and you're going to have to repair a bunch of blades. They're really only worried about making sure they meet that minimum level. They're not going to be, I assume that they won't be proactive to get them up as soon as possible and to be, maximizing yield. But maybe they've got some sort of bonus payment in there. I don't know. But like I said, I'd really love to see these contracts, because developers are so trusting of these OEMs to, give them 30 years.
If they only had somebody consulting in Australia that knew those details, they could help them. I just don't know anybody, though. Do you?
Well, that's why I'm so interested, because I'm the one who's in the conversations trying to translate between Danish engineer and Australian developer, and make sure that all the problems are under control. So I wonder if we we will be hearing from that developer at Offload Consulting. Maybe we'll be working together in the future.
So here's a question for you, Rosemary. If we go energy sale to the grid, now let's calculate this. I got a spreadsheet open here. Any energy sale to the grid at a kilowatt hour, what's a wholesale price in Australia right now?
Well, it varies obviously from day to day. I can look it up right now and tell you what it is this second.
40 cents?
Just opennem.org.au, and if I go onto one day, over the last 24 hours, we've seen 257.62 per megawatt hour.
Okay, so 257.
So divide that by 1,000.
Yeah. So
$257. Is that what you just said?
Yeah, it's an expensive.
That's an Australian though, right?
Expensive day.
That's almost an American dollar.
Yeah, they're
so like 160 or something US. Yep.
So I'll go.
See what I'm saying, Joel?
That's crazy. So 160. That's one.
No, but that's not the average.
No.
That's the immediate price, right?
So
spot price.
Yeah, but that at a
actually it's 162. Oh, I misread that.
So
Joel, we got to install some wind turbines in Australia.
So with that spot price right now this is in US dollars. If you're at 16 cents a kilowatt hour, that's about 24,000 US dollars per turbine per day. With the size of that wind farm, you're looking at almost 3 million US dollars in revenue per day. Now that's at 100% capacity. So if you drop 1% of that, I mean, you're talking that's 30 grand. If you drop 1%. So they must really trust in that if you're talking, if they're trying to hit a minimum and they're just kind of bouncing through there, if they drop 1, 2, 3, 4, 5%, 150,000 a day, if you're at 5%, that's crazy. So, I mean,
yeah, I agree. It's something that I can't get my head around why there's so much of it here, because before I came back to Australia, the operators that I was working with were really proactive about, trying new maintenance strategies and operational strategies. I was working, that would mostly be Canadian ones. I was in a few wind farms in Quebec where they're pretty innovative. And then, in northern Sweden, but those were just farms under construction. And I talk about it when I'm at conferences, industry conferences in Australia, trying to find out. And the impression that I get is that we're just at this different phase of the whole cycle in Australia, where developers are really focused on the next project and getting projects underway. Just more and more and more. That's the kind of easy money at the moment. And I expect that in 5-10 years, when that all slows down, that then people will be more worried about, getting that 1 or 2% from existing assets. And I mean, it can be more as well. If you've got an actual problem in this strategy, then you could definitely see 5%. And some of the, I often get brought in to look at serial defect problems where, they've got to eventually take down, every blade on a wind farm, or at least, stop them for a week or something to do repairs on, maybe not every blade on a wind farm, but, on the affected population, which, could be 10-20% of blades. The speed that you do that and the way that you do it as well, making sure that you're doing, non-urgent maintenance on days when the wind isn't good or the price of the wholesale spot price is low. There's huge differences that you can make by, strategizing on that. And it just really surprises me that the OEMs are so hands-off. But I have also noticed that they seem to be kind of hands-off in the contract stage when, contracts are being developed and agreements are being signed. But later on, when there's a defect, and the OEMs that I have worked with, which is most of them by now, are exclusively terrible at communication. They, it's like, oh, we've got a serial defect. Don't worry about it. We've got it under control. And that's kind of the end of what they will communicate at first. And so then the developer's like, well, actually, we don't have anybody on staff who knows anything about blades. We've got no way to tell if what they're saying is reasonable or normal or under control, or if this is going to be a huge problem. Becomes especially a big problem if you want to sell an asset or refinance or anything. Then, you need to actually know where you stand. At that point, I think maybe developers, operators are wishing that they had thought about it more at the stage of the contract. But like I said, I don't quite understand, but I think it's maybe to do with maturity and just the fact that it's just all systems go for getting more turbines in the ground now. That's what everyone's spending their effort on. And there's only so many engineers in Australia, and they're all working on development as far as I can tell.
Yeah, with those energy prices, Joel, I mean, those would be dream prices in America, right?
Yeah, but like Rosemary said, that we'd have to look at what the levelized cost is over the year to kind of do an apples to apples.
Yeah,
otherwise,
that was one day, and PPAs aren't maybe all that much. You have to give me some warning, and I can put together some stats for next week's episode if you like to get a more broad representation. I'm actually not following the spot price every day because I think you're a mechanical engineer, not an analyst.
I think your supposition is about perfect though, Rosemary. Everybody's focused on getting these things in the ground. So all the engineering effort is on development, and then it's just once they're in, hand it off and we'll move forward. But that may come back to bite them in the butt a little bit.
Lightning is an act of God, but lightning damage is not. Actually, it's very predictable and very preventable. Strike Tape is a lightning protection system upgrade for wind turbines made by WeatherGuard. It dramatically improves the effectiveness of the factory LPS so you can stop worrying about lightning damage. Visit weatherguardwind.com to learn more, read a case study, and schedule a call today.
Rosemary's talking about all the developments happening in Australia up in Queensland, which I guess is like the Silicon Valley of Australia, from what I can tell, is set to become one of the largest wind farms in the southern hemisphere, not just in Australia, with the Queensland government announcing plans to double the size of the McIntyre wind project. So the project already is about a gigawatt, and they're going to bump it up to 2 gigawatts. So it's 180 turbines moving up to 360 turbines. Yeah, gigawatts. Sorry, from 1 gigawatt to 2 gigawatts, right? So that they figure it's enough to power about 1.4 million Queensland homes. That's a lot of homes. The Labor government in Queensland, as part of this deal, is talking about establishing a blade factory in the next couple of years up in Queensland. The blades that are coming from this new project or the expansion project will be coming from India, which makes sense. But this seems like with all the activity in Australia, they're wanting to work with somebody, maybe one of the OEMs, maybe one of the operators, to create a wind turbine manufacturing facility in country. That makes sense. But Rosemary, as you were just saying, engineers, they're all kind of tied up working on projects. Is the infrastructure there for Australia to open a blade factory?
It's not ready to start tomorrow, but when new wind turbine blade factories are opened, it's usually somewhere where they haven't made wind turbine blades before. It's not a problem. It's not like highly skilled labor. I know I was looking at some of the job ads for an LM factory that was opening somewhere one time, and it was like, if you've ever manufactured anything before, then that gives you a big head start, but you don't have to have. So, all the training's provided. So I don't think it will be such a huge problem. To me, it makes sense to, if you're going to make an industrial hub, it would make sense to put it somewhere that already has a lot of industry that's maybe declining. So, there's a lot of coal mining in Queensland. So perhaps we can, take some of those workers and get them started making wind turbine components. There's a lot of areas like that. I was just visiting one at the Hunter Valley, where Newcastle was a bit north of Sydney, and that's, coal country. And, back when we used to have climate change wars every election, the conservatives would always be campaigning in these areas like, oh, look at all these people who will never work again if we do anything about climate change. And I was up there because I was having a look at a bunch of clean energy projects that are there. There's, a bunch of startups and just innovative projects by established companies. And all of them are saying, we need workers, and the skills that we need are really, really similar to mining industry or, other, thermal power generation workers. So I would assume that there would be skill transfer, or that would be the way to, maximize the effect. And since, as you mentioned, it's a Labor government that wants to do it, then it would make sense that they would be concerned about the workers that will be affected when they do this big, ambitious transition that they're planning.
Would there be a company that could operate that business? Who are there companies in Australia that could just add on to their existing business and add on a blade business as part of it? Is that something in play, or do you need to bring in someone like a TPI, which has plants all around the world, to come in and to start it?
For blades, I would be just highly surprised if it was just an Australian company. And I know I did read an article by a commentator who I really like, but he was saying that Australia makes surfboards, so why not wind turbine blades? And I don't think that is a relevant skill transfer. They both use foam and fiberglass, so there's that. But wind turbine blades are largely handmade. But I think it's that whole big structure of quality control, and or it's not so easy to make a profitable wind turbine blade factory. You've got to get a highly choreographed dance practically to get these blades, hundreds of people making these blades and getting them out the door one every day, for operating 24/7 to get value out of it. So I think for blades, It would definitely be an existing manufacturer. Otherwise, I would expect it to fail. Sorry. But I think there's heaps of components in a wind turbine that Australian manufacturers could step up to make. And I know there's already some, parts of towers being made, and, all sorts of other stuff. And a lot of it obviously has to be made on site. Like, you're not going to, your foundation has to be kind of, put together in place. It doesn't work otherwise, and a bunch of other stuff like that. So, I think that will be the easiest. And if we are going to have blades made here, then I guess that it will be TPI. I mean, I saw an article this week, maybe another one that you shared, Alan, that TPI is talking about expansion into other regions, and immediately tweaked in my brain. Oh, is one of those Australia? I would love to see it. Love to help. Give me a call if you need some help setting up, because I would love to see a wind turbine blade factory in Australia. That would make me very happy.
Yeah, well, and blades aren't the only thing that Australia is going to need to develop. And it sounds like Australia is already pushing forward to a 100% renewable grids. So there's a little bit of technical work to do there still. The Australia's electricity market operator has laid out an engineering roadmap. From what I can tell, it looks like they're trying to get the grid to 100% renewable, which is easy to do at times in sort of a statistical way. Like, yeah, we're making enough energy to get to 100%, but we're also sending energy outside of our neighborhood to power other places. So those things tend to be really temporary. It's happened in the United States in a couple of places. But in Australia, they're talking about making a 100% renewable grid and having a stabilized grid where they don't have a lot of natural gas / coal backing it up. And there's a couple of hurdles there still. The first one is you have a lot of output, right? And you have a lot of variability. You have a lot of rooftop solar, and you have wind and some hydro, I assume. How are you going to manage all that? And then it's all electronic, right? So the inverters and everything is feeding the grid. You have to have some control over those inverters, and are they doing what we think they're supposed to do? So Rosemary, it sounds like Australia is going to be leading that effort to really have a standalone grid. Are there resources to do that? That's a complicated thing to accomplish. It seems like you would need a lot of engineers working on just that problem alone to get a 100% stabilized grid.
Yeah, it is going to be really interesting, and it will be significant for the world when this happens. And I think it's important to point out, like, we've got a pretty progressive government now, but only for less than a year. They've been in. Before that, the government for the previous decade was very against renewables. And so this getting to 100% renewables, it's not the result of a government saying we need to get to 100% renewables and forcing it. It's been the market that's done this. It's just, now it's just the cheapest way to generate energy most of the time, and it's the best way that you can make money. If you want to, start a new energy project, then you'd be crazy.
Sure.
If it was anything except for wind or solar in Australia, plus heaps of rooftop solar as well, which, is a decision made by each household. And so we're going to get to that point. How are we going to manage to do that without just, wasting a bunch of energy? And like you said, this report, it lists the kind of nuts and bolts of what we're going to need to make sure is done by then, so that the grid doesn't just collapse the first time.
Right.
Because if you just leave the market settings in place and all of the thermal generators, the big spinning mass, if they all get the signal that you need to turn off because you're losing money for staying on, then the grid becomes really unstable if you haven't thought about how you're going to do it before. So there's a bunch of challenges. You mentioned some of them. And yes, there's a lot of electronic control of the grid with batteries, for example, and synthetic inertia, they call it.
Right.
But there is also the possibility for synchronous condensers, which they're trialing in South Australia now, which is basically, it physically mimics a big thermal generator. So it's a big mass that you use electricity to spin it up, and then it's got that actual mechanical inertia keeping it spinning no matter what happens in the grid. So that's one way to do it. And then the batteries that do the synthetic inertia, that's probably the next step after that. And there is some experimentation being done in South Australia, one of the states in Australia who's kind of like led this transition. They've already had plenty of times where they have instantaneous 100% renewables. But the key difference is that they've got interconnection points to the rest of the main Australian grid, so they can import and export there. So it doesn't matter so much what what goes on there. But they have been doing a lot of experiments with how to maintain stability, and they're down now to, you have to always have at least 2 thermal generators running now to make sure there's that inertia in the system. But they're going to try soon to go to 0 and just use these synchronous condensers and synthetic inertia. But there was a little bit of a natural experiment recently when there was a storm that knocked out the main interconnector and just left 2 tiny ones. So they were basically islanded for a while. And there was a period of really strong, renewable availability during the days at least. And so they did have more renewables than they could use and had to curtail a lot. And that's why one of the things you're going to need to see happen when you get up to the whole Australian grid being 100% renewables is we're going to need a way to control all of the different things. You can't just have rooftop solar pumping electrons into the grid, no matter what happens, because that could be really destabilizing at those times. And, bearing in mind that that's actually rooftop solar, it sounds tiny, but it's actually, when you add it up, it's a major source, bigger than any single generator. So there's a lot of things to be taken care of, but I was really excited that it's 2025. This is predicted to happen. It's not a target that happens in 2025. It's a prediction. It's like, this is coming and we need to be ready for it. And so, we can hold our breath and wait and see what happens, and hopefully AEMO makes sure that we're ready for it.
As the electrical engineer here, those things scare me, right? So the power quality is a huge issue. Maintaining the frequency on the grid is a big deal, and keeping the voltage level stable is an amazing feat that we've seen to do fairly well at this point. We're adding a lot of variability back in, and Joel, from what's happened at ERCOT that they've had a lot of trouble with a relatively small grid compared to what Australia's about ready to do. Is there ways that we can sort of leverage what we're doing in the States and learning in the States and what Australia's about to do or doing to provide some stability to the grid? I'll add another element to it. Joel, did you see that Tesla was announcing the semi-tractor trailer is operational? That they did a long 80,000 pound load run for I think it went 500 miles recently in the last couple of days. So they think that those tractor trailers are going to be on the road, and that we're going to be putting a pretty large demand onto the grid that we hadn't planned for.
Yeah, like we were talking about talking about the other week that if we have power charging stations for those trucks, that each of the power charging stations, they'll take as much power as a small city to charge all those vehicles. What I'd like to see, so we were talking about this off air a little bit, is with our listeners being all over the globe, it's nice to get a little bit of some information and news from all over the place. And it's really cool what Australia is doing. To me, they're a larger society, right? Like the Danish society runs a lot on wind power, but it's a little bit easier to manage, right? There's only like 5 million people, and you can drive across the country in 3 hours.
And it's connected.
And it's all connected to right. Australia is an island, and you can't just export everything offshore or to a different country easily enough. So I think that there's a lot of really big lessons to be learned from what Australia is doing down there right now. And I would like to see some of these U.S. operators, ERCOT, we always talk about ERCOT because of who they are and what they've done. But a lot of these other operators and these other interconnects is to look at what's happening there and to learn from it as we move forward. Because they're years in front of where we are. As far as I'm concerned, I know we talked a couple months ago about MISO putting $10 billion into the infrastructure just in the Midwest. I mean, and these big transmission lines are talking about planning going from Wyoming all the way to California, and so we're still. I mean, everybody's as the grid changes in every country and every market, we're still adjusting what the infrastructure looks like. But we shouldn't be putting this infrastructure in just just run some cables and throw up some towers and we'll make it work. We should be thinking about it as we go and adjusting for these things. So what Australia is doing is something that the operators and the engineers in the U.S. and globally need to be watching, because they're ahead of the game, I think. Yeah,
we just visited the Hoover Dam recently, and if you look back and see how massive that project was and what it was intended to do, how it has evolved over time. It's about a 100-year-old project at this point. So it's paid for itself a couple times over, I assume. But yeah, you're talking about doing Hoover Dam type projects right now, but in renewables. That's what's happening at the moment, and how big of a cultural change that was for that part of America. Yeah, that's coming. That's really coming. That's going to be fascinating to watch. Really is. Dogger Bank and Tesla has put a big battery at the output of Dogger Bank, which is an offshore wind farm off the coast of the United Kingdom. So they've added about 100 megawatt battery. It's about 200 megawatt hours. That's right at basically just onshore. So all the energy rolls in offshore, plugs into this battery, which is there to provide a little more stability. So again, as Joel, you were talking about, you're seeing the world take on these different projects to stabilize the grid with renewables. There's another one, case in point. And yeah. I think, Rosemary, as we were talking about before the show started, you didn't think that was a very large project, but it's just the first, right? It's the first of probably several.
Well, space is a little bit more limited in the UK than it is in Australia. That could be a reason.
Yeah.
Battery doesn't take up very much space. No, I was just I was surprised to see it described as the biggest battery, because I checked and I think there's five bigger than that in Australia, and Australia is a much smaller country, so population at least.
Population-wise,
yeah.
right.
So I was a bit surprised, but it is really interesting to see that they're adding a battery to existing plans. The big battery in combo with a solar farm or a wind farm or both that I've seen have usually been all developed together, or it's been a standalone battery somewhere else. So it's interesting to see it being added on. And I was also interested that it's an offshore wind farm. One of the topics that there's a lot of interest in for energy startups recently is offshore energy storage. And to me, battery onshore, where the good connection is, that's the place to do your offshore energy storage. So yeah, now we're seeing that actually happen. That will set the benchmark for what any of the exciting new kinds of ocean energy storage have to beat. So yeah, look forward to watching how it plays out.
So you think there's going to be how many gigawatts or terawatts of battery? How many terawatts would the UK need? I think they said 4 terawatts in America is a rough number, if I remember correctly.
If it's
100
yeah,
gigawatts
but they're always
kind of thing?
The projections are always so much like, this is how we run our grid now. We're going to make it look exactly the same in the future. And it's just not going to be like that. We are going to get better at flexibly changing our, the time that we use electricity, as well as flexibly supplying electricity. There's just no way we won't, because the last bit of storage, to make the system look like it does now is just so ridiculously expensive. I mean, I've seen when petrol prices, when there's one petrol station in town who has 10 cents a litre cheaper than everyone else, you get people drive 30 Ks to get there. They wait an hour in their car to fill up and save a couple of dollars. Like, you're telling me that there's not enough people who will care that much about their electricity bill, that they're not prepared to, do everything in the middle of the day when, solar's at peak levels, or, in other ways be flexible. I find it so crazy that we think that we're just definitely going to do things exactly the way we do now, because that's what everyone's used to.
I think that will come.
That's my opinion.
That will come, Rosemary. So one of the reasons why you have that with the fuel prices is it's so dang visible. You drive around and there's a big sign that says, here's how much the price is. To date, you don't get that. Like, the energy prices, as far as electricity going in your home, that doesn't happen. Now, when you talk about, last week or 2 weeks ago, we talked about an app-based system that you look at your phone and you can see how much energy you've been used, how much money you're making, all that kind of stuff. As that becomes more commonplace, I think you will have. I mean, one of the biggest things in energy, and my humble non-electrical engineering opinion, is people just waste energy. I mean, it's back to when you were a kid, like close the refrigerator. What are you doing? Like, turn the lights off, like that kind of stuff. But that is something that we don't, as I know, as an American society for sure, we don't take into consideration that much. But if you had on your phone, like your phone was like, ding, hey, you've used $10 of energy already today. Oh man, I better turn these lights off. So, if as that becomes more and more common, I think you might have people actually conserving energy, at the and instead of using it in waste is my thought.
Yeah. I think you're definitely right that the first step is awareness. And, I mentioned that I worked with some, really innovative wind farm operators in Quebec. And I remember this one, I walked into their office and they had this huge screen up with the current price of electricity. And it was like, I don't know, it looked like a gambling screen or something. It showed how much money they were making every minute. It ticked over, and and that really drives, do I really need to go up and, check the, whatever talk of the de-icing system bolts in today? Do I need to do that today when, we're making so much money? Maybe I'll save it. I'll look at the forecast. Okay, it's going to be less windy later in the week, or it's going to be more sunny, so the price of electricity will be lower. And the same with some of the innovative companies in Australia. I went into Neoen's operating room and had a look, and they've got like a thousand screens in there with numbers. And very prominently you can see exactly what the price of electricity is and what they're earning. Maybe it'll be the same in people's homes. You got your thermostat, and maybe there's a big number on the top of it that says how much electricity costs right now. I don't think that we'll be getting alerts on your phone that tells you to turn off your lights. I think that you will have programmed that, this is the minimum lighting level that you're happy with if you're home. And, some other automated stuff like that. Yeah. I was listening to some other podcast, a competitor. I can't remember the name, so I can't mention them and draw viewers away from this one. I can't remember the name, but they were interviewing somebody who has, like a similar kind of thing to the app that I was talking about in Australia that helps people manage their, time of electricity use. And it was saying one of the most useful things that their app does is it's watching the state of charge of the battery in your electric car. And so if it knows you're at home and your car battery is low and that you haven't plugged in, then it will send you a reminder that says, hey, did you mean to not charge your car? Because, it's about to be, it won't have enough for you in the morning. So there will be ways that they can add value to the customers, draw them in with something that improves their lives. And then I think from there, it'll be a reminder that says, if you had agreed to be on our flexible plan, then you could have saved $20 last night because, there was this event that you couldn't participate in because you were asleep or stuff like that. I don't think it will be as intrusive as your thermostat being, or your air conditioner being turned off, or your
you go like, I'd like to turn it up to 72.
An alert on your phone every 5 minutes. Telling you what you need to get up and do, or it wakes you up at 2 a.m. Put your laundry on now. Like it's not going to be like that.
I'm thinking
it'll be a bit more user friendly. I think
when I woke up this morning, and this is what I'm thinking about. We have like the Nest thermostat where it's really user friendly. Actually, the user interface is. But I'm thinking like you push the thing and then you turn it, and it's like it'll be 72 degrees in your house in 25 minutes. And I'm thinking like if it said like this will cost you $7.46. You sure you want to do that? Like, ooh, $7 that might pay for lunch. Nah, 70's fine.
It could do that. It could already do that. You can already forecast the electricity price, or it could know your tariff, or
But economies are based on energy. They just are. But
they're not based on wasting energy, and we waste so much energy.
Sure? Have you met America yet?
Yeah, but it doesn't have to be. Oh, yeah, I have.
Okay.
I have met America. I have opinions about the way you use energy over there.
No, you can have opinions about it. I'm just saying every country, every nation, every development that has happened because of the availability of energy. And that could be in human form, or it can be in nuclear, oil, whatever. You pick your poison. But that's how societies grow, and that's how we get there. You're not going to see a country willingly cut energy production or cut the amount of energy that's delivered because that without something significantly happening in
What
culture.
about energy
I just don't see
efficiency? What about if you have a huge cold store in your company and you get onto a wholesale pricing plan and now you turn the freezer on in the middle of the day when you get paid to do it because prices are negative, and then it will maintain its temperature right through to the next time that happens. Like that company is making more money now by using energy in a way that helps the grid. I just think it's going to be things like that. It's not going to be about not using any energy to do productive things. It's about using it smarter, much smarter.
Yeah. Okay. I'm with you. I'm obviously, if there's a financial advantage to use less energy, people are going to do that, or companies in particular are going to do that. It just gets to the point of it becomes too much to manage. And you're a new mom, right? And you know how time management becomes super critical. Do you think you have time to check the status of your electric vehicle, make sure it's charging all the time, or what your thermostat's set at? There's some things that can be done. Yeah, you sort of run out of time in the day, right? And I think when these projects always pop up, and you see a lot of SaaS companies in the United States that are talking about these projects, and I think, when is the time if someone's going to do this? When the average citizen's going to do that? I don't think that's going to happen. I think it's going to be more of engineering people like everybody here of, we're going to design more efficient homes, we're going to design more efficient cars, we're going to design more efficient airplanes, which we've all done, by the way. We've done all those things. So it is...
But you find time to go to the petrol station and fill your car up. So I think you can find time for some new things. And I think also the successful companies are going to be the ones that don't require their customers to make more time. Some people will be happy to trade off time for money, like the person that's happy to sit in their car for an hour to save a couple of dollars or filling up their tank. And some people are going to be happy to hand over, tell an app what parameters they're happy with in their home, never go below this temperature, never go above it. Sure. I always need my dishwasher finished when I wake up in the morning, stuff like that. And they'll be happy for a smart app to take care of the rest. All
right. So I'll give you the Rosemary theory of relativity, right? Every time we bring up a topic like this, it's like relative to what, right? Replacing lights in America and incandescent lights with LEDs is probably one of the largest power changes that's happened in America in the last 20 years.
But it's taken 20 years.
Yeah. Oh, no, it's taken 20 years.
Still
but you
going
think
on.
how much energy... Yeah, but think about how much energy we are using less. We're using less energy now in lighting. All the street lights in America are going to LED at the moment. Those are huge numbers that we don't talk about. Right? We talk about changing the thermostat all the time. But the real numbers are in sort of these wider scale projects that we pay short shrift to all the time. And it just makes me crazy to think, people have worked their whole lives making those LED lights, right? And what a huge power saving that is, and how much power is in the United States in particular, it goes into lighting. How much energy reduction that is where we haven't built power plants. We haven't built that coal plant because we've just switched light bulbs. That's what I'm getting to. There are things that we can still do at that level, which are easier to do and probably have more impact than turning down our thermostat. Not that we shouldn't think about that. We should. But, there's plenty of engineers working really hard to make life a little bit easier. And I think that's one of the things we just miss.
Ping Monitor is a continuous blade monitoring system which allows wind farm operators to stay ahead of maintenance. Wind techs can often hear damaged blades from the ground, but they can't continuously monitor all the turbines. They also can't calculate how bad the damage is or how fast it's propagating based on sound, but Ping can. Ping's acoustic system is being used on over 600 turbines worldwide. It allows operators to discover damage before it gets expensive and prioritize maintenance needs across their fleet, and it pays for itself the first time it identifies serious damage or saves you from doing an unnecessary visual inspection. Stop flying blind out there. Get Ping's ears on your turbines. Learn more at pingmonitor.co.
France's highest court has ruled that a man fired by his Paris-based consulting firm for allegedly failing to be fun, or quote unquote fun, enough at work was wrongfully dismissed. So they actually fired an employee in France because he wasn't fun. So in the holiday spirit, it gets to where we're all going to holiday parties, at least in America. And I guess it sounds like Denmark has a really good blowout season in Christmas parties. I thought this would be an interesting topic to talk about. So the man referred to in court documents as Mr. T was fired from Cubic Partners in 2015 after refusing to take part in seminars and weekend social events that his lawyers argued, according to court documents, included excessive alcoholism and promiscuity. So I don't know what's happening in France, but it just seems like that's not really quote unquote fun.
Is it?
But isn't it odd? I just think it's such a weird thing to have happen in France. And in America, I could totally see it. There's 330 million Americans. Stuff happens like this all the time, unfortunately. But to not be fun doesn't seem like a reason to get fired.
Isn't it really hard?
It's weird, right?
It's really hard to fire someone in France anyways by their labor laws.
I thought so too.
So this guy must have been really not fun for them to make that move. I mean, he must have been like, I would call him a Debbie Downer. He must have been like the Debbie Downer of Debbie Downers or something.
Right.
I sympathize with Mr. T. I don't want anybody telling me when or how I have to have fun. I leave that's a decision for me. And I will say, though, that I really miss the Christmas parties in Denmark, which definitely there was a lot of alcohol and they definitely have a reputation for promiscuity, but I never actually saw any evidence of that myself. So it might be one of those urban myths. I definitely miss that. And I did find that fun, but I wouldn't think, you can't pressure somebody to get drunk if they don't drink alcohol or just don't feel like it on that particular day. I don't think that's right. And I definitely have been in situations through my career where I felt like, to fit in culturally, you had to do some non-work stuff that wasn't really your preference. It is important to, have a team building and have fun together, to, get to know your teammates and develop that relationship. But I said, I feel for this Mr. T fired for being not fun enough.
I keep reading this. I'm reading this article and I keep thinking about The Wolf of Wall Street, if you guys have ever seen that movie.
Yeah,
that's what I'm thinking. Awesome. Like, man,
that's too much fun.
Yeah, exactly. That's what I'm thinking here. Like, Mr. T maybe has a point here.
No, I think some moderation is probably good. The courts actually ruled that he was entitled to his freedom of expression. So not participating is his expression of where he wants to be at that moment, and that was part of his fundamental freedom under labor and human rights laws in France.
So I
guess are they? I don't know if he's reemployed at this company he doesn't like working at.
Probably not.
Is that what happens? Or he get paid out?
I would say here at the.
I hope he got paid out, but I think they also mentioned one of the reasons for getting fired was the tone and facial expression he used in meetings or something.
Yes.
And that just kind of triggered me from when I lived in America. People used to tell me to smile all the time, just random strangers. And I would be like, this is my face. Like I get to choose
really
what
happened.
I do with my own face.
Rosemary.
Like, come on. What?
You must have been in California. That's the only place that would occur.
I was in California.
Okay.
It happened constantly. It happens very occasionally in Australia, but almost never. And in Denmark, I just actively just enjoyed looking at everybody scowling in front of their computers every day. I'm like, it's work. It's work. I'm here. I'm working hard. My resting face is not a smile. It looks like a frown, even if I'm not actually upset. And I would feel pretty put out if my company told me, your facial expression is wrong and you have to plaster a fake smile on your face every day. Then, that would be a bad cultural fit and I wouldn't want to work there. But if I got fired for that, I would not think that was reasonable.
No, you're right. It's a holiday season. Have a little bit of fun, but keep it within the bounds, right? I think that's I think it's where society is at today. Years ago, Christmas parties used to get a little way, in my opinion, I would have been that guy who was not having fun. Like, this is out of bounds.
Much.
Everybody's just being stupid here. Right. It's too much fun. We've gone past too much fun. But they seem to have reined it in a little bit. So it's fun. I think it's now enjoyable to meet with coworkers or people you haven't seen in a little while, that you can spend some time together, and it's not in a work environment where it's sort of drudgery, because most people, at least in America, tend to be a little bit pleasant, and you can have some fun with them. Yeah. I don't know. I'm not going to talk about California or Denmark. I don't know. But from what I hear, Denmark is a lot of fun in terms of Christmas parties, that they actually take days off.
Yeah, the Christmas party.
Afterwards.
They save it up all year. It's fun quota each day.
Can confirm.
Up and
Can confirm.
It's all unleashed in the Christmas party.
That's going to do it for this week's Uptime Wind Energy podcast. Thanks for listening. Please take a moment and give us a 5-star rating on your podcast platform. And be sure to subscribe in the show notes below to Uptime Tech News, our weekly newsletter, as well as Rosemary's YouTube channel, Engineering with Rosie. And we'll see you here next week on the Uptime Wind Energy podcast.